Alright, so here's the answers to the first question from your review. This picture will be given to you on your test, and you'll be basically asked to find all the missing angles and all the missing sides. I wrote in all the missing angles and missing sides here. So this was given as 90 degrees, this was given as 90 degrees, this is 34 degrees. AC is 30, okay, and FE is 21. So since FB is a perpendicular bisector, AB and BC is 15. By Pythagorean theorem, 15 squared plus 20 squared equals 25 squared. Since AF and FC represent distance from a point on the perpendicular bisector to the end points of the side that's perpendicularly bisected, AF and FC have to be equal. So this is 25 and this is 25. By Pythagorean theorem, I could say 20 squared plus CD squared equals 25 squared, and doing the math there, you get CD equals 15. These three sides will always be equal because we're dealing with three congruent triangles, actually. And then finally, BF is 20, FD is 20. Since FC is an angle bisector, F is equidistant from the sides. So when FB is 20, FD would have to be 20. Okay. Based on the Pythagorean theorem, 20 squared plus DE squared equals 21 squared. 400 plus DE squared equals 441. We subtract 400 on both sides, and we get root 41 for our DE. In terms of angles, if this is 34, this has to be 34, because it's an isosceles triangle, and the angles opposite congruent angles have to be equal. Since this is an angle bisector, these two angles have to be equal as well. These angles have to be 90 because they're linear pairs. 34, 90, and 56 equals 180. 34, 90, and 56 equals 180. 34, 90, and 56 equals 180. And then 56, 56, and 56 equals 168. 168 plus 12 equals 180. And then 12 plus 90 plus 78 equals 180. So that's how I get all the missing angles. When you're given a perpendicular bisector, you're creating right triangles. So this side is 4, therefore this side is 4 since it's a perpendicular bisector. 4 squared plus this side right here squared equals 5 squared. So 16 plus this side squared equals 25. We subtract 16 on both sides, we get 9. Square root of 9 is 3. Okay. This side right here is 4 squared plus this side right here squared has to equal root 65 squared. So 16 plus this side right here equals root 65 squared, which is 65. 16 plus this side equals 65. Subtract 16 on both sides, you get 49. The square root of 49 is 7. So AC would actually be 10. 3 plus 7. And since this is on the perpendicular bisector, CD and CB have to be equal. So if this is root 65, this is root 65. When you have a centroid, the distance from the vertex to the centroid is double the distance the centroid to the midpoint. So if I double 2y plus 2, it should equal 5y plus 1 because EG is double GB. When we double 2y plus 2, we double it, we get 4y plus 4 equals 5y plus 1, and my y equals 3. And you can always plug these back in to check them. This becomes 8 when you plug 3 in, this becomes 16 when you plug 3 in. The distance from the centroid to the midpoint is 1/3 the entire line. 11z minus 12 represents CF, excuse me. So if I triple 3z plus 1, which is multiplying it by 3, I can set that equal to 11z minus 12. 9z plus 3 equals 11z minus 12. Subtract 9z on both sides, add 12 on both sides. We get 15 equals 2z, and my z is 15 halves. 5x plus 1 is 2/3, or 8x minus, or excuse me, 2/3 of 8x minus 1 is 5x plus 1. The distance from the vertex to the centroid is 2/3 the entire line. So if I take 2/3 of 8x minus 1, it should equal 5x plus 1. We multiply both sides by 3, and then we distribute the numerator on the left and the denominator on the right. That becomes 16x minus 2 equals 15x plus 3. We add 2, we subtract 15x, and we get x equals 5. Finding the centroid, we find the midpoint and connect it to the opposite vertex. Find the midpoint, connect it to the opposite vertex. Find the midpoint, connect it to the opposite vertex. If you want to find the exact point of the centroid, you have to find the equation of two of the lines of the medians. So if I find the equation of the line from median C, which is right here, my slope is 1, my y-intercept is 5. So y equals x plus 5, and that turns into x minus y equals negative 5. From B, I get y equals negative 5x minus 11. The line is a slope of negative 5. So if I go down 5 over 1, down 5 over 1, I get to a negative 11 y-intercept. So y equals negative 5x minus 11. We add 5x to both sides. 5x plus y equals negative 11. And now I solve my system. 6x equals negative 16, and my x is negative 8 over 3. When I plug negative 8 over 3 minus y equals negative 5, I change that negative 5 to a negative 15 over 3. I add 8/3 to both sides, and my y equals 7/3. So there's my centroid, negative 8/3, 7/3. For an orthocenter, now we got to do a slope and do the opposite reciprocal. An orthocenter means a line that goes from the vertex and forms a right angle with the opposite side. So from B, what's the opposite reciprocal slope of AC? So 1, 2, 3, 4, 5, 6 over 3. So this slope is negative 6 or positive 6 over a negative 2. It's a slope of negative 3. So the opposite reciprocal is 1/3, up 1 over 3, up 1 over 3, up 1 over 3. From point A, I need the slope of BC. Slope of BC, down 2 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down 2 over 10, it's a slope of negative 1/5. So a positive 5 over 1 slope from A. I'm going down 5, left 1. Down 5, left 1, down 5, left 1, and that's my altitude. Okay. From C, I'm going up 1, 2, 3, over 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so my slope is, from AB, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So my slope is a positive 1/2. So this slope from C is going to be a negative 2 over 1, up 2, left 1, up 2, left 1, up 2, left 1, and there's my altitude. My orthocenter's in the middle there. Okay. Once again, if I want to find the exact value of it, from point A, the equation is y equals 5x minus 10, which turns to 5x minus y equals a positive 10. From point C, the equation is y equals negative 2x plus 9. We add 2x to both sides, and we get 2x plus y equals 9. When I do linear combination here, I get 7x equals 19. My x is 19 over 7, and then I plug it into an original. 2 times 19 over 7 plus y equals, I change the 9 to 63 over 7 and keep that common denominator. When I subtract 38 over 7 on both sides, my y equals 25 over 7, and there's my orthocenter. From an obtuse triangle, my centroid is still going to be in the middle, vertex to midpoint, vertex to midpoint, vertex to midpoint, and I'm doing the same thing. I'm finding the equations of the lines, and then I'm using a systems of equations to get my x and y. The orthocenter from an obtuse triangle on your test will meet an exact point. They don't have to, but I'll make sure on your test they meet an exact point. My slope of AB is up 4, left 2. So it's a slope of negative 2. So therefore from C the slope is 1/2. Down 1, left 2, down 1, left 2, and goes straight through here. From side BC, the slope is negative 1/3. So this slope from A has to be a positive 3 over 1. Down 3, left 1, down 3, left 1, down 3, left 1. And then from AC, we're looking at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A slope of -1. So the slope from B is going to be +1. Up 1 over 1, and then down 1, left 1, down 1, left 1. And we draw the line. All three altitudes meet at the orthocenter, which is -1, -2. Putting them from shortest to longest, it's really about one side being the longest of one triangle and one side and that same side being the shortest of another triangle. So BE and BD are our key sides. If you look at BD first, it's the shortest side of BED. It's the longest side of BDC. So the shortest side of BDC has to be the shortest side of the picture. So that's CD, BC, and BD. Now when I come to this triangle, while BE is the biggest side of BED, it's the smallest side of AEB. So we go CD, BC, BD, ED's got to be bigger, and then BE. And then my final two sides, AE, the second biggest side of this triangle, and AB, the biggest side of the biggest triangle. The key here is working off your shared sides, though. The hinge theorem, if we have two congruent sides, the side opposite the bigger angle is bigger. Since AD is opposite 46 and AB is opposite 45, AD would have to be bigger than AB. When we're trying to find the measure of angles, when you have two congruent sides, so AD equals DC and DB is shared, so angle ADB and angle CDB are what we're working off of. Since angle ADB is opposite 12 and angle CDB is opposite 13, angle ADB has to be less than angle CDB. This angle right here is bigger than this angle right here because it's opposite 13 and this is opposite 12. The angle opposite the bigger side is always the bigger angle. The side opposite the bigger angle is always opposite the bigger side when you have two congruent sides of a triangle. Finally, the range of the third side, keeping in mind the two smaller sides always have to be bigger. The sum of the two smaller sides have to be bigger than the third side. We just simply do 8 minus 6 is 2, 8 plus 6 is 14. My range is between 2 and 14. 19 minus 12 is 7, 19 plus 12 is 31. My range is between 7 and 31. When you're given x's, you combine two of them and make them bigger than the third. 2x plus 8 plus 5x minus 3 is 7x plus 5, which is greater than x plus 7. When you solve, x is greater than 1/3. Then we do x plus 7 plus 5x minus 3, which is 6x plus 4 is greater than 2x plus 8. My x is greater than 1. And then finally, 3x plus 15, the first two, has to be greater than 5x minus 3, and therefore x is less than 9. When we have two greater thans, we always pick the bigger number. 1 is less than x, which is less than 9. Here, 3x plus 12 plus 7x minus 2 is 10x plus 10 is greater than x plus 8. X has to be greater than -2/9. X plus 6, or 8x plus 6, which comes from x plus 8 plus 7x minus 2, has to be greater than 3x plus 12. That's 5x is greater than 6. X is greater than 6/5. And finally, x plus 8 plus 3x plus 12, which is 4x plus 20, has to be greater than 7x minus 2. And that becomes x is less than 22/3. One, we can't have a negative number here anyway, so it's got to be the higher number. 6/5 is less than x, which is less than 22/3. Right? And you do want to make sure, especially for your lowest number, that it doesn't create a number lower than 0 on any of these, which my lowest number here will not create any zeros. My lowest number here will not create any zeros.